We're at gotomath.com and working some calculus problems. We're down here at related rates, and I need to make sure. Okay, there's not a 10-4. Of course, I don't think any of these problems have 4 in it. Maybe one. This entire section. Oh my God, what is this? Okay, time to write something down. Let's sketch it down on a piece of paper so we can work this out. We have a 19-foot utility ladder, and I'm using English units here. Feet. I usually been using metric, but we'll throw some feet in here, okay? So I hope that doesn't confuse. I know most of the world uses metric. We've got the scientific world and the math world and all that uses metric in the U.S., but your average person, your journalist doesn't. We got 19 feet. Utility ladder leans up against a vertical wall. The ladder slides down the wall at a rate of, so slides down the wall. That's going to be dy over dt, by the way, at a rate of 5 feet per second. 5 feet per second. Find the rate of change of the distance from the base to the wall. That's going to be dx over dt is what we're looking for when the base is 4 feet. And that'll be x is equal to 4 feet. Okay, I think we got everything we need. Now I'm going to draw a picture so we know what's going on. So we'll draw a wall, and you know what? We'll just draw a brick wall. How's that? It's a slick brick wall. We're going to draw a brick wall here. We're going to attempt to draw a brick wall. How's that? There's our brick wall. So we said that our ladder was 19 feet long. So this is going to be 19 feet right here. This is the length of our utility ladder. All right. And it's sliding away from the wall. It's sliding away from the wall. And that, I believe, in this problem here is what we're trying to find, dx over dt. At what rate is it the base of the base, this is the base here, it's sliding away. All right, so this part of the ladder is moving down the wall, sliding down the wall. Okay, now we're going to say that the height, or we're going to say, whoops, that this is y, going to be in the y direction, obviously, and this will be in the x direction. Okay. Now the rate is dy over dt. This is the rate at which it's sliding down the wall, and we said that that was 5 feet per second. And when it gets out to 4 feet, all right, x is equal to 4 feet. When it gets out to 4 feet here, okay, what is, how far, or what is the rate dx over dt? Okay, so we got that. Now we're working with a right triangle. So x squared plus y squared is equal to r squared. So that's what we're going to be working with right here, since we're working with a right triangle. Now, here's some things that we're going to need to know. We're going to need to know what y is. We need to know what y is, right? We don't know what y is. We don't know what dx over dt is, right? So we need to know x, y, dx over dt, just writing down some of the things we need to know here. Dy over dt. Well, we know x is 4, but we don't know what y is. So let's go over here and find out what y is. Okay, so x is 4 squared plus y squared is equal to, and then this is going to be 19 squared. All right, so let's go 19 squared minus 4 squared, square root all of that, and that will be our y. Okay, so we got 19 squared minus 16, and got so y is equal to the square root of 345. 345. Let me see something real quick here. Yep, 19 foot. Okay, looks good. I'm just checking. Okay, so we got our y, right? 345. Our dx over dt, this is the question mark, and then dy over dt is 5. So that's what we want to figure out. So we're going to need to take the derivative of this thing. And the derivative of x squared is 2x times dx over dt plus 2y times dy over dt is equal to 2r times dr over dt. Now, dr over dt, okay? Question is the ladder, the length of the ladder changing? And that is going to be equal to 0. That's not changing at all. So that would be 0, okay? Because this is not moving. This is not changing. The ladder's not getting smaller or larger. So that's 0. We're going to run out of room. So this whole part right here becomes 0. So we're going to write 0 in there. And then we can multiply through by a half all the way across to get rid of these 2's right here. So we end up with dx times dx over dt plus y times dy over dt. Alright, now we can go ahead and plug some numbers in. So x is going to be 4 dx over dt, that's what we actually want to find, plus y is the square root of 345, and then dy over dt is 5, set that equal to 0, okay? And so now we need to solve for dx over dt. So we have dx over dt is equal to I see an issue here. Okay, the this distance right here coming down the wall, okay, coming down the wall, something I forgot to tell you is the dy over dt, this rate is going to end up being negative. Okay, it's actually negative, and what the negative symbol does, what the negative symbol does here is it tells you that this distance right here is decreasing. Alright, this distance is decreasing, and I've totally left that out. So we're going to put that negative in right here. Okay, so we can't leave that out. This is extremely tricky. So you have to remember that if the distance is decreasing and we're talking about a rate, we put a negative in. We have to put a negative in here, and that tells us that the distance is decreasing. Okay, so you have to do that. All right, so we bring everything over, so we end up with negative square root. Well, when we bring this over, it actually becomes positive. Sorry, That was the reason why I seen that. Okay, because it's negative here, we bring it over, it becomes positive, and then it's all over 4 over 4. So we'll want to plug that into the calculator because we're going to be rounding to 2 decimal places. Or you can multiply that by hand if you want. That would not, that'd be nasty. All right, over 4, we get 23.22 is what I got. 23.22. So let's hit the answer here. Yeah. Okay. So we get 23.22 feet per second. All right. And remember where you are, and I'll see you there. Bye.